Math 113, lesson 6.1 is verifying trig identities. And before we actually start that, I want to do a quick review. So all the things that are here on the board are review. We've already seen these before. Our reciprocal identities, just reminding you of what those are. Our quotient identities with tangent and cotangent, and then our Pythagorean identities. These are all things that you've seen before now. You saw them in chapter 5. And these are things that you're going to need to have written down to help you do the problems that we do today. So make sure that you have this available to you as we work the problems that I am about to work. It will just make life so much easier. Okay, so when we talk about verifying, to verify an identity, what we're going to do is we are going to show that one side can be simplified so that it is identical to the other side. So for the majority of these, we are only going to be working with one side of our equation. Now, the further we get along, we will have to work with both sides, but it's always best if we can just start with working with one side and see if we can't simplify it to equal the other side. Now, something that you need to be very, very clear on when we're doing these, don't be afraid to stop what you're doing, to stop in the middle of a problem and start over. Very often that happens in verifying identities. We have to just stop what we're doing. It looks like it's not going anywhere, and just start over and try something else. Okay, so with that being said, just know that may happen. So you're either going to need an eraser or some extra paper. All right, so let's start. Example number 1, our directions are verify the identity. And here is our identity. The cosecant of x times the tangent of x equals the secant of x. So essentially what we're going to do is we're going to work with one side and make sure it can simplify to equal the other side. So I have to make a decision in my mind, which side am I going to work with? Well, it seems clear I want to do something with the bigger side, the left side. So I'm going to use those reciprocal identities to help me out. I know that cosecant is the 1 over the sine. I use the quotient identities for tangent. I know tangent is sine over cosine. Now, this other side, the secant x, I'm not even doing anything with it. Just bring it down. All right, now I can simplify. Sine x and sine x divides out to give me 1. So I'm left with 1 over the cosine of x. Again, just bringing down this right side. And then I use the reciprocals again, and I know that 1 over the cosine is the secant. So I have successfully simplified this left-hand side all the way down until it equaled the right-hand side. Please don't stop a step early, all right? We do have to completely simplify the left or the right, whichever one you choose to simplify. All right, so that's how we were going to use those identities. You are going to need them handy. If they are not beside you, make sure you go ahead and put them beside you. All right, this one will be a little bit bigger. All right, so we are asked to verify this equation. Now, again, I'm going to choose to work with the large side. So I am going to work with this left-hand side over here. Okay, and so you may not start exactly like I might start. But I know that cotangent is the cosine over the sine. And the reason that's the only one I'm doing anything with right now is now everything on that left says sine and cosine. This right-hand side, I just bring it down. Okay, so now I'm going to put a 1 up under that and just multiply. I get cosine squared x over sine x plus sine x. Just bring down my cosecant. All right, in order to add these two on the left, I need to get a common denominator. Well, to get a common denominator, I'm going to need to multiply the numerator and the denominator here by the sine of x. So that will give me cosine squared x over sine x plus sine squared x over sine x. All right, now that my denominators are the same, I can put that numerator together over sine of x. Again, bring down this right-hand side. All right, now I'm going to need my Pythagorean identities. Cosine squared plus sine squared is 1. Those Pythagorean identities. And then my reciprocal identities, I know that 1 over the cosine is the cosecant. So notice that I simplified all the way down to where the left side equaled the right side. Don't stop a step early. All right, I've got 3 more examples that I'd like to show you. They do get slightly different. The difficulty level changes a little bit with each one. This time instead of x, I'm going to use theta. Okay, now on the past 2 problems, what I have done is I just chose to work with the larger side. Well, when I look at this one, example number 3, it looks like the left-hand side and the right-hand side, they're both kind of big. So now I just have to make a decision, which one do I want to work with? And I like for things to say sine and cosine, so I'm going to leave the left-hand side alone, because I like it when it says sine and cosine. And I'm going to see what I can do to this right-hand side. All right, I know cosecant is 1 over the sine. And I know cotangent is cosine over the sine. Okay, this is looking promising. Okay, this left-hand side is just going to come down, not doing anything to this side. Now over here on the right, since my denominators are the same, I can go ahead and add that numerator and put it over the denominator, and there we go. Now we're done. The left-hand side equals the right-hand side. There we go. So that one was pretty quick. All right, let's go on. Example 4. Okay, so the last problem I told you I like for things to say sine and cosine, and so that was what I used to help make my decision of which side to work with. Well, this time both sides say sine and cosine, so it's really just a toss-up. Which side do I want to work with and try to change? And I'm just going to go with, I'm going to change the left side. All right, so my right-hand side is not going to change, and I am going to work with this left-hand side. Now, I don't want to make it say something other than sine and cosine because the right-hand side does say sine and cosine. So what I'm going to do here is multiply. Okay, go ahead. I'm going to go ahead and write down what's already here. And I'm going to multiply the numerator and the denominator by the conjugate of the denominator. So times 1 minus sine x on the numerator and the denominator. This right-hand side is not changing. It just comes down. Okay, when I multiply this left-hand side, now I'll have cosine of x. And then I'm not going to try to distribute it, okay? We don't try to distribute things. All right, and then in my denominator, when I do FOIL, okay, you have to think of this as FOIL. 1 times 1 would give me 1. Plus sine x minus sine x will cancel the middle two terms. And then minus sine squared x. So I did FOIL on the bottom and got 1 minus sine squared x. The right-hand side, just bring it down. Okay, so now we need to go back to our little Pythagorean identities. I'm going to write it down just so you can see it. Let's look at this Pythagorean identity. If I rearrange this identity and I subtract this sine x squared to the other side, then it would say 1 minus sine squared. Well, notice that's what my denominator on the left-hand side says. It says 1 minus sine squared. So I am going to replace that denominator with cosine squared x. And the reason I can do that is because of what I wrote over here. Okay, we used our Pythagorean identity. 1 minus sine squared is cosine squared. My right-hand side just comes down. All right. Now on the left-hand side, I can simplify my cosine and cosine squared. That would leave me with just a cosine in the denominator. So I have 1 minus sine x in my numerator, cosine in my denominator, which is wonderful because that's exactly what the right-hand side says. So I have verified my identity. All right, one more, and that's all we're going to do. So this is a great example of, you may have to start over. This is a little bit bigger problem. I may have to start over after I get going and see that maybe it's not looking like I want it to look. Or I may decide, you know what, this might be one that I have to work with both sides. There's no way to know without just jumping in and trying to work the problem. So what I'm going to do first is I'm going to take this left-hand side, and in order to add fractions, you have to get a common denominator. So my common denominator is going to be 1 plus sine theta times 1 minus sine theta. So I would have 1 plus sine theta is already here. I'm going to multiply by 1 minus sine theta. Whatever I do to the denominator, I must do to the numerator. Plus, I already have the 1 minus sine squared over here. I am multiplying by 1 plus sine squared. Okay, just getting a common denominator. Whatever I do to the bottom, I must do to the top. So I have to multiply the top by 1 plus sine theta. My denominator just comes down. I'm sorry, not my denominator. My right hand side. I'm just going to bring it down for now. All right, now that on my left I have a common denominator, I'm going to do a couple of things. I'm going to go ahead and multiply that out. I know that when I multiply these two out, I get 1 minus sine squared x. So as I move, that's what I'm going to do. 1 minus sine squared x. I did FOIL. My numerator over here is 1 minus sine theta plus 1 plus sine theta. Okay, and I just put it over one denominator. Bring down this right hand side. Okay, so this is looking good. I have a minus sine theta and a plus sine theta, so those go away. That does leave me with a 2 in my numerator. And I know from what we did earlier, okay, remember we did a Pythagorean identity and we know that that is equal to cosine squared x. So I know that 1 minus sine squared is cosine squared. I'm sorry, my theta somehow changed to an x. Sorry about that. So I have 2 over cosine theta. Okay, so when I reach a place like this is when I have to go, all right, maybe I should work with both sides, because this is not simplifying the way that I hoped that it would. So I'm going to leave this left-hand side like it is, and I'm going to start working on the right-hand side and see what I can do. Well, the first thing I notice I can do is change tangent. I can change that tangent to sine squared over cosine squared. Tangent is sine over cosine, so tangent squared would be sine squared over cosine squared. That's one of our quotient rules. Okay, that's awesome. So, remember this left-hand side, I'm just going to leave it alone now, just working on the right. So I have a 2 over 1 plus a 2 sine squared theta over cosine squared theta. I just multiplied this 2 over 1 times sine squared over cosine squared. All right, so on my right-hand side, I do need to get a common denominator. So I'm going to multiply the numerator and the denominator here by cosine squared. On my left, I just bring that down. I'm not doing anything on the left at the moment. So I get 2 cosine squared theta over cosine squared theta plus 2 sine squared theta over cosine squared theta. Now that my denominators are the same on the right-hand side, I can add my numerators and put it over the one denominator. Okay, still not changing the left-hand side, leaving it alone. Now in my numerator, I notice that I've got cosine squared theta plus 2 sine squared theta. That 2 is in my way. So let's factor out the 2. And the reason we want to factor out that 2 is in the back of my mind, or on a sheet of paper beside you maybe, you should see that that is the Pythagorean identity. Cosine squared theta plus sine squared theta is 1. So this left-hand side comes down again. This is 2 times 1 over cosine squared theta. And, sorry about that. That just really went far. Sorry. Okay, so my left-hand side comes down again. And 2 times the 1. Now my left side equals the right side. So I am finished verifying. Now that one was a long one with a lot of steps, and that can get a little scary. You can get in the middle of a problem and think, oh my gosh, is it going to go anywhere? Just keep working. And remember, your goal is to make the left side equal the right side. Now, we don't want to move things from the left to the right. We don't do that in verifying. So don't try to move things to the left and right. You can simplify the left and simplify the right, but don't try to move things from one side to another. All right, so that is all for section 6.1.